Hi, my name is Peter Swift. I'm Product Marketing Director at Amphenol Commercial Industrial Products based in Toronto. And I'm very happy to be talking to everybody tonight about our offering of products that are suitable for next generation connections for industrial robotics. So first question really is, what is a robot? Well, a robot is an autonomous machine capable of sensing its environment, carrying out computations to make decisions, and performing actions in the real world. We feel that that's a decision that, or a definition that seems to fit very well. Now, we all have impressions about what a robot is from popular media, but the fact is that we're surrounded by robots in our everyday lives. Devices we may not think of as robots, but some of which we have used for years and couldn't imagine living without. And then there's others which are relatively new devices. Robots are in the air above us, and in the near future, may even become indistinguishable from us. Industrial robots are highly specialized and typically much more robust, powerful, and capable. Many are fixed robots and belong to a variety of different types for various special kinds of applications. And some have the freedom to move around autonomously, and such as those found in warehouses, moving skids of product from one location to another. In all cases, these industrial robots are designed and programmed to optimize automation, ensure consistent quality, and to reduce the overall efficiency and cost of an operation. Industrial robots themselves perform the physical work, but to make this happen, unlike their domestic cousins, which typically have self-contained controls, industrial robots usually require a complex control network that combines and integrates a variety of devices which together ensure the smooth operation of a robot and provide the connection to the overall factory network. This diagram illustrates the complexity of a typical control network. And while the makeup of such networks can vary, they include devices such as servo motor drives, sensors of all kinds, input devices such as teaching pendants and human machine interfaces, as well as vision systems, and all of which must communicate with the controller, which provides the interface to the robot itself. This wide variety of devices have typically been developed by different manufacturers and has led to the creation of a number of different communication protocols, bus systems, and proprietary machine interfaces. In addition to this, a wide variety of electrical interfaces have been developed or adopted for use with different types of equipment depending on their requirements, including electrical specifications such as voltage, current, and data rate, mechanical drivers such as size, form factor, number of conductors, and accessibility, and environmental factors like temperature and exposure to moisture, chemicals, particulates, and mechanical shock and vibration. All of these electrical connections must tie the equipment together to function in a reliable manner. But in addition to the physical interfaces, there also needs to be an overall network system enabling all of the equipment to communicate. The Ethernet protocol was initially developed in 1973. And since then has undergone an evolution, taking it from 10 megabit per second in the 1980s to 10 gig Ethernet commonly used today, with the development of 200 and 400 gigabit Ethernet unfolding now. Simply put, Ethernet is a common protocol enabling flexible transmission of high-speed data used in networks we all use every day. Considering the rapid development of industrial automation networks, with the growing number of devices that need to communicate seamlessly, Ethernet is a natural protocol to enable this communication. However, there's a key requirement in industrial automation networks. Unlike computer networks that are being used by people or systems that can tolerate a lag or delay in the transmission of data, an industrial automation network requires real-time deterministic performance, meaning that the network guarantees that an event will occur or a message will be transmitted in a specified, predictable period of time. And this is typically critical in an environment where devices need to communicate and interact in a precise, predictable manner. The communication hierarchy in automated factory is evolving. Traditionally, there's a series of discrete levels of devices that communicate well within their own level, but not as well between levels due to protocol differences. This is changing with the implementation of Ethernet communications from top to bottom or from cloud to sensor. While traditionally the interconnects between the devices have been widely varied, this change in network structure is driving the need for new interconnect devices, specifically designed to support industrial Ethernet communication in a factory environment. The IX Industrial and the single pair Ethernet devices have been introduced as two new interconnect standards. They've been recently developed to support the proliferation of connected devices that need a common physical interface. Both have been purpose designed from the ground up specifically for the industrial Ethernet applications and implementation. IX Industrial and single pair Ethernet are the next generation of interfaces for industrial Ethernet. They're designed to work together seamlessly. IX Industrial provides 5 pairs of controlled impedance contacts supporting high bandwidth 4-pair Ethernet. And single pair Ethernet contains a single pair of contacts specifically for the providing of the interface to a single addressed device on the network. Together, they provide a series of distinct advantages for today's industrial networks. Unlike many of the connectors in use today, both IX Industrial and SPE provide a smaller form factor, allowing for higher density where multiple connectors are used, as well as being more suitable for smaller devices. IX Industrial provides Cat6a connectivity for 10 gig E communication, and SPE up to 1 gigabit Ethernet for individual devices, supporting the demands of real-time deterministic networks. While the connectors are new, existing chipsets are used for RJ45 modular jacks are also supporting IX Industrial for the silicon for single pair networks, and the silicon for single pair Ethernet is also now available. With so many devices such as sensors and actuators being added to increase the complexity, to increasingly complex networks, power delivery can become an issue. Both IX and single pair Ethernet support power over Ethernet to eliminate the need for separate external power sources. Both connectors are designed in accordance with industry standards and standards group acceptance criteria for transmission requirements, including insertion loss, near-end crosstalk, far-end crosstalk, and signal reflection. IX and SPE are both available in IP20 and IP67 configurations for harsh environment applications and are specifically designed with features such as robust metal latching and 360-degree electrical shielding for reliable performance. Both have a broad solution portfolio with a variety of mounting styles and cable configurations, and SPE with its two-wire design means smaller, lighter, and less expensive cabling to make it cost-effective and with an ability to support more devices. Finally, both connectors interfaces are available from more than one manufacturer, ensuring a robust, competitive supply chain. Amphenol's portfolio of industrial Ethernet interconnect products include IP20 and IP67 variants of both single-pair Ethernet and IX industrial connectors and cables, as well as industrial modular jacks, plugs, and cable assemblies to support the entire spectrum of interconnect needs in this rapidly expanding market. Amphenol is also developing and supporting the expansion of these standards with more new products. In addition to single-pair Ethernet per IEC 63171-6, Amphenol is developing connectors supporting IEC 63171-7 and has also introduced recently launched a version of IX industrial board mount connectors with integrated magnetics. IEC 63171-6 specifies a single pair of traditional SPE contacts, but with the addition of separate power contacts in the same connector. These power contacts are available in a number of configurations or types, supporting 2- and 3-phase power with voltages up to 50 volts AC and up to 600 volts AC, with current ratings between 8 amps and 16 amps. IX Industrial with integrated magnetics, or IX Mag, includes an isolation transformer on each data pair to provide galvanic isolation to prevent any DC bias on the data line, as well as common mode chokes to eliminate common mode EMI. Amphenol's design supports PoE and maintains this 10 millimeter center-to-center pitch of the standard flag-style IX industrial receptacles to ensure the same port density can be achieved with the magnetics versions. To illustrate the typical uses of these connectors, we can take a look at a typical industrial robot control cabinet, which includes the logic controller, I/O ports, Ethernet switch, and controls for sensors, drives, and vision systems. IX Industrial and single-pair Ethernet are used throughout for high-bandwidth network interface and internal communication, and for communication to various external devices, including actuators, sensors, other device controllers, HMIs or displays, cameras, data loggers, and of course the robots themselves, especially where PoE device control is used in devices such as grippers. I've mentioned PoE a few times and power over data line, or POODLE, for single pair Ethernet, and these requirements are specified by IEEE 802.3 CG for PODL or POODLE and BT for PoE. SPE and IX industrial connectors support the maximum specified level of power handling defined by these standards, and in fact can exceed these specifications due to the current handling capability of the contacts, providing headroom over and above the IEEE standards. In short, the network of the devices and data communications required to support industrial robotics applications are well supported by single-pair Ethernet and IX industrial interconnect solutions. These next generation of industrial Ethernet interfaces support real-time deterministic Ethernet protocol, are rugged design specifically for industrial environments, are miniaturized as well to support increased density, meet industry standards to ensure full compatibility, provide power over Ethernet and power over data line, and are multi-sourced for supply chain resiliency. Thank you very much for this brief introduction to our products that are supporting to industrial Ethernet automation robotics, and look forward to questions you may have about these. Thank you very much.
All right, hello everybody. My name is Caleb Chronister. I am the marketing specialist for Amphenol's Power Solutions business unit. And today I'm going to be going over a couple of robotics applications and some power solutions that go inside of them. So first of all, I just wanted to go over a quick overview of our business unit. We focus entirely on power connectors, and we have 2 state-of-the-art test labs in China and the United States. We also have 4 fully integrated manufacturing facilities, 3 of them in China. We also have a fully integrated Cochin, India manufacturing facility. On top of that, we also have a globally staffed research and development team in the US, Europe, as well as Asia. We pride ourselves in best-in-class power technology, so we mainly focus on the high-density contact technology. We have connectors ranging from 8 amps all the way up to 1,000 amps per contact. With our proprietary silver-based plating, so that would be our AGT and our GCS plating that allows us to have ultra-low end-of-life contact resistance. One big concern when it comes to high power connectors is thermal capabilities. We have a great in-house thermal engineering team, and they're able to run simulations not only for our products, but also for an entire system under load in still air with airflow, 2-phase liquid cooling, and then also immersion cooling simulations. And they're able to see things like T-rise testing, hotspot observations, and test different materials and platings. And another challenge when it comes to custom power connectors is that they get designed in last. So a lot of our solutions are very customizable. One way that we do this is by fully modular tooling, meaning that we're able to customize the amount of power and signal contacts depending on what the system requirements would be. We also have other things that we can do to meet application requirements, such as IP sealing, touch-proof features, latching options. We can accommodate multiple voltages and things of that sort. Typically, we like to break up our product portfolio into a couple of different categories. Later on, I'll be going into more detail on specific robotics applications, but one of them is our one-piece solutions. These are card edge connectors, and they mate directly to a PCB. Next, we have our 2-piece blade solutions. So this is most notably our power blade family. This has been in the industry for over 25 years now, and started off with the original power blade connector. You can see each evolution up to Ultra, and later on I'll be going over the next generation of power blade, which is Power Blade Ultra HD+. We also have our low profile version, Power Blade Mini, as well as Power Max. Next is our largest and quickest expanding product line. This is our bar clip bus bar connectors. So these would mate directly with the laminated bus bar to distribute power. We have solutions ranging from 25 amps all the way up to over 1,000 amps in board mount and cable versions. And then we also have our pin and socket family. The biggest one we have here is Cool Power. We have our standard Cool Power product, which is a configurable power and signal pin and socket connector. And then over here we have our new Cool Power stamped and formed in HD, which I'll be going over in more detail later on. And then lastly, we have we call it e-power. This is our more industrial side power connectors. A lot of these are very new to us. Energy Clip was designed for energy storage systems. IPC is a battery connector used very much in e-mobility. And then we have Fit 30 and Easy Power, which are both field installable connectors. So quickly, I just wanted to go over a couple of the benefits of robotic automation and why the industry is continually growing and evolving. For one, it automates routine tasks, which can generate a reduction in costs for companies. It also maximizes productivity and can increase accuracy when compared to a human. In some places where there is a shortage of workers, it requires less workers and a reduced need for labor. And it can also increase worker safety since there's so many safety features built into these robots. On top of that, we're able to work in unfavorable environments, such as extremely cold or extremely hot locations where humans either wouldn't be able to work or they would need to have constant breaks. And in some cases, it can reduce operating costs by up to 20%. The whole industry of warehouse robotics is growing at an annual growth rate of approximately 11.6%. And with constant innovations being made by some of the industry leaders, I don't see this trend going anywhere. So the term robotics is a bit of an umbrella term. There are many different kinds of robotics. There's factory, warehouse, security. There's even service robotics now. Not all of them play very well into our power connectors, so I want to narrow it down a little bit into what are our target robotics applications. So one of them is fixed industrial robots. This mainly concerns robotic arms and the control unit interconnects with inside of them, as well as just power distribution throughout the entire system. We also focus heavily on autonomous mobile robots, also known as AMRs for short. We play in the power converters and inverters, the motor drive, different sensors and battery management system connectors, as well as the drive controller. And lastly is the e-mobility charging. So this would be charging stations for AMRs, for things like e-forklifts, transport carts, drones, and other warehouse robotics applications. The battery interconnects in particular, and the high current quick charge capabilities. First product line I wanted to go over in a little more detail is the PowerBlade product. This is our PowerBlade TouchProof. As you can see on the right here, this is an example of TouchProof connecting a motor drive to a drive controller, or the motor to the drive controller inside of an AMR. This features a squeeze to release latch and is overmolded for harsh environments, and also features a touch safe. It's rated for up to 38 amps per contact, and this comes in a 90-degree cable exit as well as a straight exit. PowerBlade Mini is a newer product for us that we are very excited to promote into robotics markets. It's available in 3 different configurations, one of them being mezzanine, also cable to board and board to board variations. All of them are rated for 45 amps per power contact, and they are a very low profile power connector. So the mezzanine is rated for 8 to 20 millimeter stack heights, and it's tooled in 1 millimeter increments, whereas the board to board versions are 8.1 millimeters height above board. The cable features a squeeze to release latch and also has a CPA, or connector position assurance latching system. And one possible application would be inside of a robotic arm for this. And next is our brand new PowerBlade Ultra HD Plus. This is the next generation of PowerBlade and has the most powerful contact to date at 100 amps per contact. This is available in board-to-board and cable-to-board variations and features a brand new optimized guide design to increase blind mating capabilities. All of our PowerBlade products are modularly tooled so that the power and signal can be configured however the application would require. And some typical applications for all of these would be an AMR, robotic arms, charging stations, and power converters. Next up, we have our Cool Power product line. This is a pin and socket connector. It has quite a few different variations of it. The first is Cool Power EV, rated for up to 115 amps per power pin. It features a large amount of gatherability for blind mate applications and is a hybrid power and signal, which can be configured depending on system requirements. This was designed for an EV charger. However, we do see some applications in different e-mobility charging applications. Next up, we have Cool Power Slim Drawer Mini. So this is a low profile pin and socket connector rated for up to 35 amps per pin and is 5.6 millimeters height above board. The standard tooling is 2 or 4 power contacts, and we also have a cable termination available. Lastly, we have our brand new Cool Power Stamped and Formed and our Cool Power HD product lines. They are very similar. The Stamped and Formed version is rated for up to 160 amps per pin, and that's at 8 millimeter pin diameter. Whereas our Cool Power HD is rated for up to 350 amps per pin at a 10.3 millimeter pin diameter. Both of these connectors come in 1 position and 2 position options and feature an extremely flexible housing form factor. We're able to wrap the plastic around the contacts however the customer would require, and we also do multiple different latching options on both. The main difference is that Stamped and Formed features a Stamped and Formed contact, so it's going to be a little bit cheaper. It's rated a little bit lower, and it also has a bit of a larger profile to it when compared to Cool Power HD, which is a lot more powerful of a contact. We also have Minisec Power, which is something that we advertise for things like sensors, motor drives, controllers, battery management system, charging stations, and fans. This is a form-fit, comparable, and compatible product with other industry providers. It features a blind mate interface, or a BMI, and that's designed to increase the gatherability when mating. It also features polarization to prevent mismating, which could also damage the contacts or something like that, so we wanted to prevent that. And this is a very small and versatile connector, which you see in all different applications all over the place, whether it's data center, consumer electronics, robotics, energy storage systems. It's all over the place because it's so versatile. And we offer it in 3 different variations. We have Minisec Power 3.0, which features a 3 millimeter pitch and is rated for up to 12 amps per contact. We also have Minisec Power 4.2, which is a 4.2 millimeter pitch and rated for 13 amps per contact. And lastly, we have Minisec Power 5.7, which you guessed it is a 5.7 millimeter pitch and rated for 28 amps per contact. The final power product that I wanted to go over was our brand new IPC connectors. This is new for our business unit. It's been in the industry for a very long time now. We are offering 4 different versions of it: a 50 amp per contact, 120 amps, 175 amps, and a 350 amp version. The typical applications you would see this product in is battery interconnects within a charging station for something like an electric forklift, as you can see in the picture here. They're rated for up to 10,000 mating cycles and are intermatable with other industry providers. They're touch safe, and they also feature color keyed housing design in red, gray, and blue, meaning that you can't mate a red with a gray as an example. It has to be the same color to mate together. And it's also a hot pluggable connector to UL standard. And that's all I had. I guess we're going to be going over to Heist now.
Yeah, thank you guys. So next to talking about very specific and nice I/O interconnect and specific power connect, I would like to share with you some of the opportunity we see in some of for PCB interconnect, which is coming from the FCI Basics business unit of Amphenol, which is known for PCB interconnect, specifically for wire to board and board to board, with some industry recognized brand names like Minitech or Microspace or Dubox. And all of these products are being developed for what we would refer to as demanding applications where performance and specifications matter. For example, for these kind of applications, right, especially around robotics. Think about the teaching pendant, the control unit, and with robotics becoming more autonomous, all kinds of radar systems, camera modules, and of course, with e-mobility also affecting robot industry, a lot of battery management systems. And if you look inside of those applications, so these are typically what I would refer to inside the box applications, you can find up to 10 different types of PCB interconnect, which we provide for these robot applications, or rather devices for robotics, from wire to board and wire to wire signal. You might think about, why wire to board, why wire to wire? Wire to wire being used typically for more module-based applications, so you can easily expand or attach modules. Hybrid solutions, which are becoming more popular in PCB interconnect specifically, because it saves space, it's easier to assemble. You can combine power distribution in one connector. So that's getting more traction also in robotic applications. And then a variety of board-to-board, depending on the size of the application. Good old pin-on-socket connectors still going strong, still popular, very used a lot. But if you go smaller, especially for camera modules, I will show in a minute, you might want to look at more mezzanine kind of types, because you don't want to mismate and destroy your application. And with many of these applications, I mean, you will see like small LCD screens. I mean, there's always a FSC connector towards it. I mean, so the interconnect content is quite substantial, I would say, for all of these applications. So let's have a look maybe at a little bit more detail where those connectors fit. And I would like to explain you some specific products and some of these specific attributes which make them interesting for robotic applications, which is of course a demanding application, because typically like a teaching pendant, I show you here as a graphic picture, is being used in a harsh environment, right? I mean, temperature changes, vibration, etc. come into play. If you look at the teaching pendant, I mean, it's similar to, I would say, almost any ruggedized handheld device, right? It has a LCD screen for which, well, by default, I would say a FFC connector is being used, because LCD screens are typically being supplied with a small flex wall towards it. What component engineers value is, for example, cable lock options, right? So that prevents unintentional cable release if you pull that LCD screen during installation. That's something we can provide. I mean, obviously, I mean, there's always an I/O, yeah, on these kind of applications. We see more and more USB-C being used. However, that comes at a cost, right? USB-C is more expensive than, for example, micro USB. So micro USB is still being used quite a lot. I mean, it's a proven, robust kind of a connector. With the teaching pendant comes, of course, a little keypad, right? Which is typically a membrane switch. A membrane switch you often also see on HMIs or numerical control. We have a very nice connector for that, which is called clincher. This connector has the terminals pre-assembled in the housing, so it can easily be placed on stock. There's a little lid you can open. You can place the membrane switch in there with a simple tool. You can close those contact gas-tight connection. This is based on a what we call a PV contact system with a beryllium copper spring. So highly reliable connection for such a well, simple membrane switch. And obviously the teaching pendant is connected to the main control. That's typically being done by wire to board connections, either pure single or a combination. Typically what's being used for those pendants is a wire to board system called PV, that comes from perpetual virgin. This is a connector system based on a dual metal spring contact, so high mating forces. This connector can mate up to 1,000 times without losing normal force, so very reliable. And you don't even need to have an active latch for this, because the retention force is high enough to perform for teaching pendants. And as I mentioned, we see more and more combination of signal and power being used. This is an example of combo lock as an example. That's a relatively small connector, got this, this signal pins, and also so power up to 20 amps. This connector can handle for the connection of the teaching pendant to the control. And with every PCB, I mean, don't forget, I mean, if you count all the connectors, there's always a test point on there, right? Even a simple little small header being used, that also adds up to the total content of PCB interconnect, in this case for a teaching pendant. And if we look at more subsystems, I mean, with these robots becoming more autonomous, I mean, you saw the examples on the warehouse robotics. I mean, moving around, they use cameras, they use LiDAR systems or radar systems, basically. They use control systems. And there's plenty of interconnect on there, specific interconnect. Again, I mean, for camera modules, I mean, it depends a little bit on the building practice of the component engineer. I would say some prefer board-to-board, typically mezzanine connectors. Mesostack is a really good camera connector because it's small pitch of 0.5. It's a hermaphroditic connector, so you only need to have one piece which mates with the equivalent. Can transfer the required speed for cameras, and it's small, and it's blind mateable, right? So there's no way during mating you can damage the contacts because these camera modules are small, right? I mean, if you use a pin on socket system, there's always the risk that you damage some contact. So that's why these mezzanine connector systems are being used. Mostly board-to-board, I would say, for these small camera modules, but sometimes you also see like these FSC, FPCs. And these modules are typically small. And what's typically being used is this SFVR system. So that's a connector, small, very small FFC connector, only a profile height of 0.9 millimeter. So that's very, very low profile. And again, with cable lock, so it prevents unintentional cable release once you pull the cable or during installation. So from the camera module, we go to LiDAR, which is more the radar system, right? This is also what we see in other industrial applications or in cars, obviously, right? Typically, it's a main board with a smaller controller board attached to it. Higher pin count connectors being used, typically board-to-board. And interestingly enough, I mean, what a lot of these robot customers are looking at is more of automotive grade type of interconnect, even for board-to-board. So they're always looking at, what kind of vibration tests do you comply, right? And we typically use some of the US car vibration testing requirements to qualify these connectors. For example, this Bergstrap 0.5 millimeter connector, which is therefore very suitable for LiDAR applications. Industrial areas, connections like the whiteboard mini text being used with an active latch, so you really need to push that latch and to unmate this connection. I mean, obviously, again, that's meant to prevent unintentional cable release. I mean, these applications are being used in robots where there is vibration, temperature change, etc. So you need some kind of reliability, which Minitex offer. And if we look at the control side, the control boards, I mean, a variety of interconnects being used. A lot of pin headers we see being used, like Bergstrap. They're typically made with receptacles, which we call Dubox, and all these receptacles of Amphenol FCI are being based on dual beam contact systems. I mean, that's typical industrial requirements to have dual beam contact systems because that's more reliable over time. And even still, you see what we have in house, what we call Quickie, is an IDC, so insulation displacement connector. IEC still being very popular. I mean, this is 45-year-old technology, but for control boards, very popular because it's a very easy method to connect a relatively high number of strands from board to board with simple tooling. Yeah, so you don't need trim tooling. You need like a flat metal tool to push the cable into this connector and make a reliable connector. Yeah, so in these type of systems, so like a camera controlled or LiDAR system, you see up to 8 different types of interconnect, which we have in our portfolio. And last but not least, I mean, but very important, what we see more and more, of course, is these battery operated systems, right? And if we look at the battery packs itself, right? I mean, typically what this comprises is different battery cells connected to each other, yeah, which can be done by a bus bar, can be done by a cable. But for us, I mean, as a PCB interconnect, the interest is, and also for customers, the interest is, how do you control, how do you measure temperature changes, voltage levels, etc. And that's being done with help of a battery management system. That's really a fast growing application. But typically there are 2 building practices. Either you do it with a flex, FPC connector, or you do it with discrete wires. That depends a little bit on the design preferences of the component engineer. Also about cost. I mean, typically FPC is a little bit more expensive, but it's easier to install. So it depends a little bit on multiple factors. You can imagine that, with discrete wire solutions, the wiring complexity is higher than with a flex. Typical connectors being used here are automotive qualified connectors, because a lot of the battery management system technology is coming from automotive requirements, driven by automotive markets, by leaders like Tesla or others. So for battery management systems, regardless what kind of industry, the component engineers are typically looking at automotive qualified connectors. FlexLock is a leading system for flex connections. And you might think of, hey, that's strange, that's rather large pitch connector. Yes, that's true, and that's because there needs to be a certain pitch to allow for this proper connection, as opposed to discrete wire, where you see a microspace as a leading connector. That's for the discrete wire. That's on a staggered footprint of 1.27, so really high density, I would say. So these are typical connection being used. And to come back on that FlexLock 254, that's of course because of the creepage and clearance distances required for this kind of application. So automotive qualified connectors is typically what also robotic manufacturers are looking for when it comes down specifically to battery management systems. If you look further to battery management system itself, you typically see some add-on boards, and that's where some typical proven interconnect systems like Bergstack are being used, 0.4 or 0.5 or 0.8. That's a kind of a family, and also more and more hybrid. So again, combo stack as a board-to-board hybrid connector. That's a typical connector for battery management systems as well. So distributed power and signal up to 20 amps per contact with all contacts powered. And again, of course, it saves space, and it also solves some tolerance issues if you have only 1 connector versus 2 for signal and for power. So this is a kind of an impression on what kind of interconnect you will see on the PCB side for robotic applications. Just as a little overview, so quite a lot of board-to-board interconnect opportunity for robotics applications, flex for the foil, and a lot of industry standard solutions like these modular systems for internal wire-to-board, board-to-board connections. So that was the quick preview from PCB interconnect point of view. Back to you, Laurie.